Hi guys, bit rough around the edges here. Really need to shave. In this video, I'm gonna do collision detection and reaction for the world. So basically the sort of bounds of the world. So keep the frog inside the bounds, and I'm also going to do collision detection on the goals at the top of the screen, and also um, adding the frogs themselves to the homes, and then reacting when they enter the home, and also if they try and you enter another frog into the same home that's already been occupied. Whew. Anyway, all of that starts after the fade. Back at it again. All right. So I noticed that there was uh, an issue with this. It's not starting in the right place, um, and the reason why I know is because the actual real Frogger game doesn't start where I've got it to start. It should actually start um, 16 times 7. So it should start 7 frogs along. So there should be 1, 2, 3, 4, 5, 6, 7, 7 of those lines, and then there should be 6 lines on the other side. Now, what that means is we have a bit of a problem for what I want to try next, which is I want to get the frog home. However, the way that it works is you can't actually get the frog home because he can't fit in the box. And the reason why he can't fit in the box is because there's actually logs that float, and then he jumps the log in and he can get into the slot. It's a kind of cool way of doing it. So you basically can't do a big long run up from the middle because there's no such thing as a middle. The other thing I want to fix is if you get your little frog character, you can actually go out of bounds. So we want to stop the frog going out of bounds. So this is going to be get the frog home and stopping them from getting out of bounds. And we also need to, at some point, reset the position back to the start. So what I'm going to do is just leave that for now. I think we should work on the collision just now. So if we go down to player controller, this checks to see if you are going right, or if you're going left, or you're going vertically, or whatever it is. Then you can go in that direction. So I'm going to find out the position of the player, and if the player is at a certain position, then I'm not going to allow it if they move up. So for example, if you move down, the maximum, where are we? See, I've been doing some research here. The maximum you can do if I run the game, see, I was expecting to go back into edit. This is why Unity kind of gives you this false sense of security. So you can see here that the Y value is 224. So if the Y value is 240, we can't go beyond 240. The actual arcade machine allows you to wander your frog along the bottom here. So that's interesting, or at least the one here. So if I play this one here, if I play this full screen, you can see that we can wander the frog around, and when we press down, then you can actually go into that position there. It won't let you go beyond that, but you can go here. So, and then obviously die when you hit that there. So this is what we're going to be building, is this game here. So for those of you who don't know, I know this is the 3rd video in, but there we go. So if keys down and model.position.y is less than 240. So if the position is less than 240, then we can allow them to move down the screen. And then similarly, if the model .position.y is greater than, that's going to be 16. So now that fixes the vertical part. So we can go down into this, you can go down the screen, and we can also go up to the top of the screen. Although you'll never actually reach the top of the screen because you'll actually die, so it's kind of redundant. But if we head up to the top of the screen now, we see that our frog stops at 16. You could probably make him go to 0, to be honest, but he's not going to make it beyond that point there. And then similarly, when he goes down to the bottom, you can see that he's now stuck on the bottom of the screen. So that's the frog inbounds now. Now for the left and right, we're going to say and model.position.x, x is greater than 0. So if they're going to the left, you want to do that. And then for, if we do let's do the right one. What happened there? What am I doing? What's happening? Where I press? I don't know what I'm pressing there. I think I'm running the game. Okay. So if we go over to the right here, you'll see that it's 208. So so long as it's less than 208, we can let them move to the right. So we can say and model.position.x is less than 208, and that will then clamp it inside the rectangle of the screen. So we can go right across to here, and that stops the frog, and then we go right across to here, and that stops the frog, and then down, that stops the frog, and then eventually up here, boom, that stops the frog there. So that's fixed the collision detection for that. Now we need to figure out how to get home and also reset the position of the frog. So let's work on that now. Where are we? Make it read only. Okay. Right. What was I going to do there? Yeah, that's what I was going to do. So the first order of business is the model needs to change slightly. So I actually need it to be 8 less than it actually is. And the reason why I need it to be 8 less than it actually is, so I'm going to put that back once we've done all this, done this video, but I should compile faster. It's taking its time. Here we go. So it means that we can do like a straight run through, and then that gets us into the frog hole thing. Okay. So what is that going to be? Well, that's going to be basically a controller. And the controller, where are we? We're going to say add, and then let's call this home controller, or lily pad controller, or goal controller. Let's call it goal controller. And goal controller is going to implement iController. So it's going to implement that interface there, and it's going to check to see where the player is. So this is going to have public goal controller player model equals model private read only player model there, and then we add models. That gives us that there. And then we're going to check and see what the position is inside there, but we also need to set up the goals. So we're going to have two fields here. So we need a goal, which is the rectangle, and we need a Boolean to say whether it's occupied or unoccupied. Okay, which means we need a model. So if we go to models, then go to add, and then click on class, and then we'll call this goal model. And goal model is going to have public bool occupied get set public rectangle area get set public goal model rectangle area equals rect. Actually, to be honest, you don't want to see that picture. To be honest, we probably don't need to change this rectangle because it's always going to be that value, and then occupied is going to be false because we're not going to have anything in there. Okay, so that is our goal model, and then we are going to have another class here called goals model. Let's call it goals container model, or goal container model. Let's not use plurals. Goal container model, and that is going to have a public ilist goal model goals get public goal container model goals equals new list goal model, and then we want to do so the goals themselves. If we scroll up to here, you see that the goal starts at 8, and then we increment it by 1, 2, 3, 8, 24, and we do that 5 times. So we're going to say var start x equals 8 for var I equals 0, I less than 5, I plus plus, and now we're going to create those values. So the x value is, what is that, 8, 16, 24, 32. Okay, so the y is going to be 32, and the box is going to be 16 because it's all 16. So I'm going to say var rect equals new rectangle, and then we need the start x. Actually, it's just going to be x, isn't it? So it's going to be x, and then the y is going to be 32 because it's always going to be 32. The width is always going to be 16, and the height is always going to be 16. And then we can actually just wrap all this inside one line and make it totally awesome. Goals.add new goal model, and that. So that adds everything in there. Then we're going to do x plus equals 24, and that gives us all our goals. So now our goals are just represented by just a hit point. That's all they are, is just a rectangle there. And now we want to do, we now want to see if inside the controller, we want to say if model dot, model, actually it's going to be for each, I'm going to do goal container model, goals, private read only, goal container model, goals, and you can make this as object oriented as you want. There's 1,000 ways to write this program, and this is just one of them. So don't feel like I'm forcing you down a path that you want to do it. You could do this as a straight up, functional version. You don't need to go heavy into the classes here. I like doing this. I like using the MVC pattern. Some would say I like using it poorly, but I find it kind of clears my mind. But it's whatever makes sense for you. You don't have to use this way, but hopefully you're finding some entertainment and help from this anyway. So set up the goals is easy now because all we do is goals equals goals, and I've spelled that wrong, and that goes as there. So now inside here I do for each var goal in goals dot goals, and then I say if goal dot area dot intersects, and then it's going to be and then I need to figure out the player rectangle. So I can do var player area equals new rectangle, because I can figure out where they are in space, because I know where they are in space. I can say player rectangle, and that's going to be model dot I'm going to change that to player position dot x model dot position dot y, and it's always going to be 16 by 16, and I need to convert these to integers, and that's fine. And then I'll say player area goal dot occupied equals true, and then I want to say model dot let's call this reset position. Now I haven't created this function yet, but it's basically going to drop the player down to a reset position, and then let's create that just now. So if I do control P, or control period I should say, sorry, I can generate the method on that model, and then I'm going to change this from model to player and rename that, and so that's everything there. And that gives us our update, and then there's also going to be a to do what if this slot is occupied, and also I can do a return here as well, so that we can immediately break out of that for loop, because we don't want to check every other for loop. Okay, and then the reset position, I'm going to say position equals new vector 2, and then we're going to do 16 times 7 minus 8 comma 224, because that's what the value is we have up there. Okay, so just to recap, I created this very basic class called goal model. It's got two properties in it, one called occupied, which has got a yes or no flag. Then it's got the area, so we can draw the rectangle, or so we can figure out the collision detection for that particular home goal that we want to land in. Excuse me. Then we've got our goal container model, and our goal container model is just a list of those goal models, and that's how we create them. That's where we generate our goal model there. And then the goal controller, it checks the player's rectangle against every other goal rectangle, and if it intersects it, then we know that we have a goal. We have achieved a frog in the goal. So now if we go down to our game state, where are we? States, game state. We can now have controllers.add new goal controller, player model, new goal container model. Okay. And I think that's it. The difference is, I think we need to reset a few things inside the player model as well. So position, we need to set the frame as well. So frame has to be set to there, and flip equals none. So we're not flipping anything, we're only doing that there. And the player controller, actually player controller needs to know that. We're doing that wrong. That controller needs to know that, so we can't do that in there. We need to do that inside player controller. So player controller, here's player controller. So we have our update there, and we want to do public reset position. So this is going to be, this is all going to be model. Oops. Turn it. Model dot that, and then we want to reset the animation. So we want to say animation equals null. Animation equals null, because we don't want to move the player when we're doing that. So now we've kind of coupled the player controller to there. However, we can have, we can also have inside there add class. Let's call that reset. Reset. So we can have class. It's actually an interface, and this is going to be iReset, and this is just going to be void reset. And then in goal controller, we can pass in reset, 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 set. I'm going to read it. Read only, reset, reset. And then down here, instead of calling that, we do that reset. Okay. So that will reset the player, and then down here we do iReset. So it's now implementing iController and also iReset. And it's just a kind of neat way of not relying on a particular thing to reset. We could call reset game, like this game state could be the reset. In fact, we might even want to do that. So the reset might do, okay, when you want to reset, then you're actually going to call, you know, a bunch of things. Like, for example, you might, you know, put 200 or something, like a score bonus. I mean, that would be part of the reset animation, and it would play those values. It plays those animations. So it could be anything. So this is kind of making it a little bit more flexible. So where's our player controller? Our player controller is down here, so we need to get that out there. Player controller, and we do var player controller equals that, and then we do player controller. So that's going to reset those things there. Okay. And there's a lot of ways that you can make this, you know, you could read it at runtime, which one of these implements iReset and then create a list of things and yeah, a whole bunch of other things. But this should all work. It's not going to work. Okay, so here's our little frog. So if we move up to here, so when we move into here, oh, there you go, it did work. So we need to reset the keys. Yeah, we need to flush the keys. Yeah, see, it's not flushing the keys. So we go to player controller. I think you can do keyboard dot get state flush keys. Put input dot. How do you flush keys? Flush keys. Handling keyboard. Flush. Oh, that was good. I just did a Google search there in a minute. I mean, what we can do is we can have a cooldown as well inside here, and then that would mean that we're not pressing anything. So it's getting press keys here, so we could have a cooldown. So let's do a private static float cooldown. Can we do the same thing that we do for the animation? Like, can we have like a generic cooldown and then just run that? Maybe we could do that. Let's do that. Add class cooldown. Public cooldown float duration. Public void update float delta time. Float current private float current equals nothing, and duration is going to be that. So we're going to say current equals 1f, and then this is going to be current minus equals delta time divided by duration. Duration equals blah. Read only. And then we can say duration equals 1f equals duration. And then we can have public bool complete get, and if current is less than or equal to 0, complete equals true. And set that there, and then say if complete return. Okay, there you go. Little simple cooldown object blobby thing. So I'm going to say private cooldown null, and then I'm going to say cooldown equals new cooldown 0.5. If cooldown is not equal to null, cooldown dot update delta time. If cooldown dot complete If it's not complete, return. Otherwise, cooldown equals null. So create a cooldown that lasts for half a second. Call the update. If the cooldown isn't null, then call update. And if it's not complete, return. If it is complete, set it to null, and then continue with the rest of the update. Okay, so that should cool us down for that half a second for update. To give you that kind of breather where you can go, oh, like everybody did back in the day in the arcades. Because they threw root beer over themselves. Oh, that's why. Just waiting for the compile. Here we go. Okay, let's try something else. Okay. Zooming up, zooming up, zooming up. There we go. Let's try another one. Okay. And that didn't work. Why did that not work? Okay, well, luckily we're going to work on this one anyway. So obviously we have a controller, we have a model, but we don't have any views for the goals. So we're going to have a view for the goals. So if we go down to views, and so I'll get rid of controllers there. So we go down to views, add, and then this is going to be goal view. And goal view is going to be base view, implement that, and generate constructor, which is that. And so that takes in the sprite batch. We also need to take in goal container model goals. And that's going to be private read only. We also need our blocks as well. So if we go to our player view, I think. So we have blocks here. So I'm going to go and grab that again and paste that in there. And then go to our blocks and paste that in there. And probably have to add that as well. Okay. And then the draw is the new for each var goal in goals. And what I want, it's goals.goals. And what I want to do here is, I mean, you can fix that with like an enumerable. You can make that enumerable, and then it'll just iterate through there. But I will leave that up to you to do that, rather than having a goals property. Okay, so for each goal, you want to draw that particular object, and that object is going to be one of these frogs here. I think they're blinking actually, so we'll need to fix that when we do the animations. So 0, 1, 2, 3, 4, 5, 6. Let me try that again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's make it 10. We want to do blocks.draw. Position is going to be goal.area dot top left. That'd be top dot that would be top there. Oh darn it, what am I doing today? Do you know what the problem is? I'm using my Mac more. That would be left, and the keyboard's different. That's my excuse. And that one there. And then the frame is going to be 10, and then color white. So it's going to draw all the frogs in there. Now, obviously, we don't have all the frogs in there. Oh no, I need to. I'm running that, and I didn't actually compile it in. So we go to game state, and then go to the views. We can do. This is a new container model, so we need to put the goals here. So we do goals. So that's going to be goals are, and then we do views dot add new goal view state machine dot game dot content sprite batch, and then it is goals. Okay, and we'll rebuild. Rebuild, keep rebuilding, and then once it's finished, we'll actually play the game. Whew. I seem to spend most of my time waiting for this to finish. Is it gonna finish? Let me rebuild that. I shouldn't have to build. I don't want to build this every single time. It seems to be building the content every single time. And I don't know if we need to do that. Ah, there you go. So 1, 2, 3, 4, 5. So it is building 1, 2, 3, 4, 5. It is building those 5 there, and you see that it's put it into the perfect area, but it's just not adding the right place. So if I go back to our goal container model, which is where we put that in there, and you see that we're doing it as our X is adding to 24. So what is adding to that? X plus equals 24. That seems right. Seems legit. So come in here, and X is 8. And now X is 32. X is 56. X is 80. X is 104. That doesn't seem right. Yeah, that's not right. That is definitely not right. Let's run that game. Have I done my math wrong? Okay, so that is it's almost like it should be double. It should be 48. I think that's the problem. Come on, compile. There we go. Okay. Okay. That works. And so if we go to the view, goal view now, we can say if goal.occupied, do that. So now when we run it, the goal won't be occupied at the very start of the game. So now we don't have anything, and we move our little frog up the screen, and we move into here. He occupies the thing there, and so on. And then we can do all 5 frogs. So that is the game complete. Well, that level complete. Now we move on to the next one. Okay, so that's good. All right. I'm going to leave the video off at this point just now. I think that's doing enough. Or at least we're not going to add any more functionality. However, I do want to do some tidying up. What's the thing that was bugging me there? There was something bugging me about that when I was playing it. Oh, that's what I wanted to do. I remember it was something to do with occupied. Memory like a sieve. Okay, so the model's there, occupied. Oh, that's what I want to do. So if I go to the model, I want to say public bool level complete, or goals filled. Int count equals 0 for each bar goal in goals. If goal dot occupied count plus return count equals 5. So I just wanted to add that so that we could test to see if it was filled. Pardon me. And also, I don't want inside the, where are we? Goal controller. I want to, if goal dot occupied is not occupied. Okay, let's do that way. If it's not occupied, we want to. Oops. We're going to handle general collision detection in the next video, because I've got a funny feeling it's going to be a little bit more complicated than that, because I don't want to go for pixel perfect collision detection, but I do want to nudge up the area that the collision happens on the sides. So if I just go straight through here and then go to here, then I shouldn't. Yeah, it shouldn't affect this one because you've already put that in there. So if you try and if it's already occupied, I think you die. I think that's what happens. Is you just get killed. So I think that's okay. So like if you just miss it, I can't. Can I show the mouse when I'm in here? Let me just go to the game, Frogger game. Initialize mouse dot set cursor, mouse cursor dot arrow. I just want to, so I can see so I can show you where the game is, because I think it by default it turns it off. Hopefully this will turn it on. No, it didn't. Pants. Okay. I can't really show. Actually, you know what? I'll take a screenshot. So, excuse me. If I go to here and then I just zoom in here, what I'm gonna do is I'm gonna mark the collision so that it starts like it's this area here. That's not a good way to show it, but you know what I mean. Where's the draw? Oh, here we go. Shapes, rectangle. Yeah. So it's gonna be like, it's gonna be like that's the natural collision detection, but really we want it to be here because if they touch this first of all, that's good. So when the player comes up and they go in here and it's not occupied, then if they miss it slightly but they touch this area, we just give it to them. And there's a bit of forgiveness in the arcade as well. And I think nudging this collision detection up just a little bit will help. Because when you're traveling, it should knock into that anyway. So we only go 16 pixels here. We don't need to check the back wall because you're never going to get to the back wall. You're either going to get killed by the frog there or you're just not going to get to the back wall. So I think having like a 16 along, 24 along here and then 16 pixels down box for the actual collision detection, I think that will work well. And we need to figure out what happens to if this is occupied. So I think if this is occupied, then you should die. So maybe we need to do that. So that is going to be what happens when you die. So let's change the goal controller. So the goal controller takes in a reset, and then the reset is going to be player home. And I'm going to rename that. And I'm going to rename reset to player home. And then I'm going to call reset player dies, or player dies. Yeah, player dies. That's fine. So it's what happens when the player dies. Now, what happens when the player dies in the next 2 seconds is going to be it resets the position. But it's not always going to be that. It's going to be something else. Player dies. So I'm going to do player dies equals player dies. Okay. And so in our game state, we're now going to pass this in twice, just for today. So if, let's take that out. So we're going to say if goal occupied, that's going to be player dies dot reset return. So if the player dies, we're going to reset them, whatever that's going to take in whatever version of it, but it's going to move them back down the screen anyway. So they're going to expire somehow. It just so happens we'll probably play a death animation and all that kind of stuff. So if I go up to here again, so it makes in the frog the first time, and why? Why is that not working? Has something happened with my cooldown? Yep. Current equals 1. Why is current equal 1? Probably because reset keeps getting hit. So reset keeps getting hit because there dies reset. Why does that keep getting hit? Reset. 104224, so it shouldn't be. Wait, that's why. Okay, sorry. Right. I want to say if it's occupied like that, else that. Okay, a little bit of a logic bomb there. Okay, so if it intersects with the player, so if we're not intersecting with the player, we shouldn't be bombing out, because at some point one of the goals is going to be occupied, like now. So I occupy this one. This is going to work, and then I move the frog up there, and then he resets back down to the bottom because he has collided into the other frog. But if I go over to this one here, that's fine because that has not been occupied. All right. Okay. Pretty cool. So we need to get the blinky frogs in. And actually, if the player resets, so player reset. What we could do is we could have a player state. Let's do that. Wow, we're on a roll. So player controller. So if I go to controllers, where did I have reset? Oh yeah, it's up here. So let's do add class reset type, our reset mode. Enum goal death. That's fairly easy. And then inside our reset, we pass in reset mode. And we do that. And then we have this here, reset mode. And then we say if reset mode equals death model.lives minus minus. So we subtract 1 from the lives. To do what happens when player gets 2 minus 1 lives. So it's a good question. Don't have the answer for that yet. But inside our where are we? Goal controller. We don't need that extra. We can call that player reset, and we'll call that player reset. Get rid of that one, that one, that one there, that one there, and then we can do player reset, and then this is going to be reset mode dot goal, reset mode dot death. Okay, so that lets probably haven't done that right. What have I done wrong? Oh yeah, okay. So that probably makes it a little bit easier to understand what's happening rather than having two separate interfaces in there. So if I go up to here, boom, and then if I try this again, let's hope that down here, this resets the number of lives. That would be kind of cool. Boom, there you go, you lose the lives. So it's amazing, all this the model view controller stuff is actually starting to pan out. Just kind of cool. So yeah, I think we're going to wrap that up there. That was an easy fix, and we got through quite a bit in this session. Whew, that was pretty cool. So we got quite a lot done. We fixed the frog movement again, or at least we started. It was more the positional start of the frog. We got collision detection done for the goals. We got collision detection and reaction done for the for both the goals and for the bounds of the screen. So the frog stays within the bounds of the screen, and the player can now enter a goal. They can now be killed if they touch a frog that already exists in the goal. So yeah, I think that's a win for this one. So anyway, thank you all for watching. Please subscribe and hit the notification bell if you haven't already. Like the video if you liked the video. Thumbs down if you didn't like the video. Please leave a comment below if you get any questions or anything like that. Again, everything's in the show notes below if you want to find out where the source code for this is. And yeah, just thank you very much for watching. Share the video as well on social media. That would be great as well if you wouldn't mind. I'd appreciate that. That would be awesome. Thank you. Once again, thank you all for watching, spending some time out of your days to watch me ramble on about Frogger. I do appreciate that. So thank you again, again, 1,000 times again. And I will catch you in the next video. Bye-bye.